Today we are going to look at the resting potential. We know that neurons are supposed to carry out the process of transduction, that is converting the stimulus into an impulse, which is an electrical information that is going to flow along the axon. We can define a resting potential as the potential difference when the neuron is not sending signals or when it is at rest. And we can say that the resting potential is always about -60 to -80 millivolts. Then the negative sign here, it means the inside of the neuron or inside of the axon is negative with respect to the outside, that is positively charged. Now the resting potential is mainly maintained by what we call the sodium-potassium pump, which uses energy from the hydrolysis of ATP. Ions that are supposed to regulate the resting potential, there are basically 4 ions. That is, we are going to have sodium ions, then we have potassium ions, we have the chloride ions, then we shall have the organic ions. Now the unequal distribution of these 4 ions is the one that is going to bring about what we call the resting potential. Let me show you how it happens. If this is our inside of the neuron, this is our axon, inside we shall have the axoplasm. Now inside the axoplasm, we shall have sodium ions, potassium ions, chloride ions, and organic ions. What is going to happen during the resting potential, using the energy from the hydrolysis of ATP, we are going to have the sodium-potassium pump pumping out 3 sodium ions, then pumping out 3 sodium ions, but bringing back 2 potassium ions. But the permeability of these axon membrane that is at rest is going to be more permeable to the outflow of potassium ions by passive diffusion. So these potassium ions are moving out by passive diffusion. Sodium ions 3 were pumped out and 2 potassium were brought back using ATP, energy from hydrolysis of ATP, meaning this is an active process, but the loss of potassium ions is by a passive process which doesn't require ATP. Then when potassium ions move out or when they are sent out, inside the axon membrane we shall have chloride ions and organic ions, because we know anions are always charged, meaning they cannot easily move outside, meaning they are going to stay inside the axon membrane. Meaning outside the axon membrane we shall have excess of the positive charge, then inside the axon membrane we shall have excess of a negative charge, because we have chloride ions and organic ions being negatively charged. Then outside we shall have potassium ions and sodium ions. Now this is going to set up what we call electrochemical gradient, meaning we have an equal distribution of chemicals and the charges are not the same on either side, that is inside and outside. Now that electrochemical gradient that is going to be set up across the axon when it is at rest or across the neuron at rest is going to be what we call the potential difference, which we are regarding as the resting potential. Now this resting potential is known to be about -60 to -80 millivolts. This is how the resting potential is maintained in summary. We are saying the resting potential is basically maintained by the activity of the sodium-potassium pump, which sends out 3 sodium ions, bringing back 2 potassium ions. Then the potassium ions, the membrane is more permeable to the outflow of potassium ions. They move out, leaving the light-sized chloride and organic ions. So the resting potential is mainly maintained by the unequal distribution of these 4 ions, which is going to set up an electrochemical gradient, which is going to be registered as the potential difference, which is about -70 millivolts, which is the resting potential.